Welcome everyone, this is Math 105, Lesson 21, Uniform Motion Applications. So what is uniform motion anyway? Well, it's motion at a constant speed. So that greatly simplifies things. We won't have to worry about things like acceleration. We're going to be using the uniform motion equation, d equals rt. That's distance equals rate, otherwise known as speed, times the time. And we are going to be solving problems like example 1. Sean is taking a trip to his grandparents' house and will either rent a car or take the bus. To travel by car will take 3 hours, and the bus takes 4.5 hours. The car's average speed is 15 miles per hour greater than the bus. Find the speed of both vehicles. So it can be very helpful to create a diagram of the situation. Got home, grandparents' house, got the car going 15 miles per hour faster, gets there in 3 hours, the bus goes in 4.5 hours, and as the diagram shows, both the car and the bus are traveling the exact same distance, and that's going to be an important factor we're going to use later. So what we're going to do now is set up some expressions for what we know. We can use a table to organize the information. That can be helpful. Now we're not given the distance, so I'm not going to fill that in. The times we are given. So for the bus, that's 4.5 hours, 3 for the car. Now the rate, we also don't know, but we don't know a relationship between the car's speed and the bus's speed. So let's say the bus is the slower of the two, and the car's speed is given in terms of the bus. We should declare a variable for the bus's speed, b for bus. And now we know that the car is 15 greater than the bus. Greater than is addition, so b plus 15 for the speed of the car. And now we can use the equation distance equals rate times time. And for each of these vehicles, we can find an expression for the distance. So for the bus, the rate is 4.5. The time is 4.5 and the rate is b. Multiplying those two together, we get 4.5b. And then for the car, multiplying the rate times the time, we get 3 times b plus 15. So we have these two different expressions, but both of them equal d. And d is just the distance from home to grandparents' house. So we know those d's are equal to each other. Since this d equals this d, this thing has to equal this thing. So the equation we need to solve is 4.5b equals 3 times b plus 15. All right, so we'll distribute here. And we get all the b's to the left. Solving for b, we get b equals 30. And then since we know that the car speed is b plus 15, that is 45. So the bus's speed is 30 miles per hour, and the car's speed is 45 miles per hour. Now to check, what we should do is make sure we get the same distance. So plug 30 miles per hour in, That's the bus's speed, and the bus is going 4.5 hours, so we do 4.5 times 30 and get 135. So the bus's distance is 135 miles. Then we'll take 3 hours, the car's time, times the car's speed, 45 miles per hour, and get 135. So we have the same distance for both of them, so it checks. Your turn, number 1. Marcy and Kendra compete in a cross-country bike race. Kendra completes the course in 3.5 hours, and Marcy finishes in 4 hours. Kendra's speed is 3 miles per hour faster than Marcy's. Find the speeds of the riders. So I'm starting by filling in the speeds. Marcy finishes in 4 hours, Kendra in 3.5. And we're also given that Kendra's speed is 3 miles per hour faster than Marcy's. So notice Kendra's speed is given in terms of Marcy's. So if we declare a variable for Marcy's speed, then we can have an expression for Kendra's speed. All right, let's call Marcy's speed M. And then Kendra goes 3 miles per hour faster, so faster is more. And that's addition. So Kendra's speed is M plus 3. So let's calculate the distance for both of these. Okay, for Marcy, rate times time, M times 4. Or 4M. And for Kendra, we've got M plus 3 times 3.5. And since they're running in the same race, or biking in the same race, those two distances are going to be equal to each other. So that gives us 4M equals 3.5 times M plus 3. And there's the equation we need to solve. So we've got 21 for M. So Marcy's riding at 21 miles per hour. And Kendra rides at 3 miles per hour faster. So Kendra rides at 24. So to check, we know that Marcy's riding for 4 hours, and her rate is 21. 21 times 4 is 84. And then Kendra is riding at 24. 24 times 3.5 is 84. So that checks. Your turn, number 2. Shin is taking a business trip from DC to NYC and is comparing flying with taking the train. In miles per hour, the airplane travels at 30 more than twice the speed of the train. If the airplane takes 1.25 hours and the train takes 3 hours, find the speeds of the vehicles in miles per hour. So we're given, if the airplane travels at 30 more than twice the speed of the train. So the airplane speed is given in terms of the train. So we need a variable for the train speed. I'm going to call that t. Now we need to translate 30 more than twice the speed. Well, twice the speed is 2t. And then 30 more than that plus 30. So the airplane speed is 2t plus 30. Now to find the distance, multiply the rate and time, and for the airplane, get 1.25 times 2t plus 30. And for the train, distance time, or rate times time, 3t. So the distances are equal, so we'll set these two things equal to each other and solve. I'm going to start by distributing here on the left. So we had 75 for the speed of the train. Now the airplane is 2t plus 30. And we get 180. So we got 75 for the train speed and 180 for the plane speed. Now to check, we'll take the plane speed, 180 times 1.25. That gets us 225. And then train speed is 75 times 3, again, 225. So that checks. We're going to look at a little different type of example now. Example 2. Sean is sick of driving the entire 135 miles to Grand Prairie house And so when they decide to get together for dinner out, he asks them to meet at a restaurant located somewhere between them. Sean drives for 2 hours and his grandparents drive for 1.5 hours. If Sean drives 15 miles per hour faster than his grandparents, then what are their speeds? There's Sean and his grandparents, and the restaurant is somewhere in between. Now we know that Sean goes for 2 hours, and his grandparents 1.5 hours. And he is going 15 miles per hour faster. So filling in what we know, grandparents driving for 1.5, Sean driving for 2. Now Sean's speed is 15 miles per hour faster than his grandparents. So we need to create a variable for the grandparents, and now Sean is 15 more than grandparents, so G plus 15. All right, so we're going to have to use a little different strategy this time because we don't know that they're driving the same distance, so we can't just multiply these and set them equal to each other. So for the grandparents, if we multiply rate times time, we get 1.5 G. And for Sean, we get 2 times G plus 15. So we don't know that these two things are equal to each other, but there is something we do know. If we look at the diagram, if you look at the distance Sean drives, and you look at the distance the grandparents drive, if we add them together, they equal the distance from Sean's place to his grandparents' place. And we know that distance is 135 miles. So that means if we add these two distances together, we're going to get 135. All right, here's the distance grandparents drove. Here's the distance Sean drove. Add them together, 135. So there's the equation we need to solve. So if we solve this equation, we get G is 30. So the grandparents are driving at 30 miles per hour. And we know Sean is driving 15 faster, so Sean is driving at 45. So we're going to check and see if the two distances driven by these two drivers adds up to 135. So if we've got grandparents driving at 30 and they drive for 1.5 hours, we know that they've gone 45 miles. And Sean is going 45 miles per hour for 2 hours. So that's 90. Add those two up and we get 135. Your turn number 3. Jack and Jill are paired together on an online dating site. After getting to know each other, since they live 165 miles apart, they decide to meet for a picnic on a hill located between them. Jack drives for 2.25 hours and Jill drives for 1.5 hours. If Jill drives 10 miles per hour faster than Jack, what are their speeds? Now we know that Jill drives 10 miles per hour faster than Jack. So her speed is given in relation to Jack. So start with Jack's speed. And since they both have J's in the name, I'm going to call Jack K. Jack's speed K. Now Jill is 10 faster, so that's K plus 10. Now let's find the distances. All right, multiply rate times time. And we are also given that they live 165 miles per hour, miles apart. So if we add up their two distances, it should equal 165. All right, so there's Jack's distance. We're going to add on Jill's distance. Equals 165. I'll distribute. And combine like terms. And we get K equals 40. So Jack is going 40 and Jill is going 50. So let's check. We've got Jack's speed, 40 times 2.25 hours. That is 90 miles. And Jill's speed is 50 for 1.5 hours, and that is 75 miles. Add them together, 165. Your turn number 4. It is 2,802 miles from New York City to LA. A Divided Airlines plane leaves from LA, bound for NYC, and an Alpha Airlines plane leaves NYC, bound for LA. The Divided plane flies for 2 hours, and the Alpha plane flies for 3.5 hours before they cross paths. if the divided plane flies at a speed that is 120 miles per hour less than 1.5 times as fast as the alpha flight, how fast does each plane fly? So here's our given information. The alpha flight is 3.5 hours. Divided is 2. And the divided speed is given in terms of the alpha speed. So we need a variable for alpha. And now divided 120 miles per hour less than 1.5 times the alpha flight speed. So 1.5 times alpha minus 120. In case you can't read that, I'll write it over there. 1.5 alpha minus 120 for the rate. And now for the distances, then we're going to multiply these out. And there's our distances. Rate times time, 3.5a, and 2 times 1.5a minus 120. Now we know the distance then from New York to LA, that's 2,802 miles. So if we add up these two distances, we'll get 2802. And so we'll combine my terms here. Get all the numbers to the right. Divide both sides by 6.5 and we get A is 468. And then if we take 1.5 times 468 minus 120, that gets us 702 minus 120, which is 582. So alpha flies at 468 miles per hour and divided flies at 582 miles per hour. Now to check, we'll do 3.5, the alpha time, times the alpha speed, which is 468, and that gives us 1638. for alpha. And then for divided, it's 2 times the speed, 582. So that gives us 1164. And if we add those two together, we get 2802. And that is it for today.